Hello everyone, so we're going to solve this problem. Determine the resultant R of the two forces shown by A. Applying the parallelogram rule for vector addition, and B. Summing scalar components. So first things first, we need to find the angles of each vectors. So we're gonna label the 400 Newton force as vector 1, and we're gonna label the 600 newtons as vector 2. So the vector 1 is equals to 400 newtons. And now we need to find the angle of vector 1. So the angle, we're gonna put this as theta 1. So the angle of vector 1, for us to make it easier, we need to find the angle of vector 1 with respect to the positive x-axis. So it is from here up to here. So that is, by the looks of it, that is a 270 degrees angle. And now for the vector 2, it has a force of 600 newtons and an angle, I'm gonna rename it as theta 2. So it is basically the same as vector 1, but plus it with 60 degrees. Does that make sense? So 270 degrees plus 60 degrees, it is equals to 330 degrees. Now that we got these values, we need to do the vector components, right? So we need to find the vector components of vector 1. So it is basically the x and y components of the vectors. So to solve the vector component, the x component of the vector 1, we need to multiply the 400 Newton, and since this is an x-axis, we need to use the cosine, and then the angle, which is 270 degrees. So if you plug that in the calculator, that should become 0. Just gonna recheck it. Yeah, that is 0 newtons. Why is it 0 newtons? It is along with the y axis, and it doesn't have any connection with the x component, so it is 0. Now if you can guess, the vector 1y, or the y component of the vector 1, is negative 400, because it is just along with the y component of the axis. So the same 400 newtons, instead of cosine, we're just gonna rename it as sine, and then 270 degrees. So that should become negative 400 if you plug that in the calculator. Now we have finished the components of the vectors here in vector 1. We need to do the same process in vector 2. So vector 2x is equals to 600 newtons cosine 333 degrees. 600 cosine 330, and we should have a value of 519.62 62 newtons. So vector 2x is equals to 519.62 newtons. Now for the y, the vector 2y, you can guess it, just change the cosine into sine. There you go. And then plug that into the calculator. We should have negative 300 newtons. So we have completed the components of each vectors. Now that we find the components of the vector, we need to add the x components of each vector. So for example, the vector 1x, we're just gonna add it to the vector 2x, and we're gonna add the vector 1y component to the vector 2y component. So that's basically it. So So the resultant vector, we're gonna rename it as vector Rx, is equals to the vector 1x plus the vector 2x. So the vector Rx is equals to 0 newtons plus 519.62 newtons. And that should equal to 519.62 newtons, or we're just gonna approximate it to 520 newtons. But instead of newtons, since this is an x component, we're just gonna rename it as 520 I hat, because I hat is the x component of the vector. So this would be our first answer. And now for the vector Ry is equals to the vector 1y plus the vector 2y. So vector Ry is equals to negative 400 newtons plus negative 300 newtons. So 4, 5, 6, 7, that should equal to negative 700 newtons, or negative 700 j hat. So that should be our answer in letter B, because that is summing the scalar components. That is our answer in letter B. Now we're gonna go back to letter A. So this would be our answer in letter B. So we just first solve the letter B, because we need the B to solve the A. So since we need to apply the parallelogram rule, in case you don't know, it is just basically we're gonna make a parallelogram with these vectors. So it should look like this. So this is the vector 2. So this 2 is similar, and we need to copy the vector 1 in this side. Put some arrows. There you go. And then to the point which they will meet, you need to draw the summation of vectors, which is right here. This is the summation of vectors of these two vectors by using the parallelogram rule. So in order to find the value of this vector, you'll just need to do the Pythagorean theorem of these two components, because this is the components of the resultant vector. So 520 squared plus negative 700 squared. So we're gonna plug that into the calculator. We should have a value of 872 newtons. And this is our answer in letter A. But we're not done yet. We need to find the angle. So we need to find the angle here. So I'm just gonna label it as alpha. So in order to find the angle alpha, we need to just reverse tangent, or the inverse tangent of 519.02 and negative 700. So since tangent is opposite over adjacent, the opposite of this angle right here, the angle theta, is basically the x component, which is the 520 I hat. So we're gonna put that in here. And TOA, opposite over adjacent, and then the adjacent of this angle is basically this one, the y component, and then our y component is negative 700. I'm gonna rewrite the 5 and the 5 more. There you go. And alpha. So alpha, if we're gonna plug that into the calculator, we should have approximate of negative 36.6, or we should just say 36.6 degrees. So these two answers here in the bottom, this one is our answer in letter A, and this one is our answer in letter B. So thank you very much for watching, and if you have problems that want to be solved, or should I make a video about it, just, I don't know, message me or just comment it below. So thank you very much for watching. Bye.